Hello everyone, welcome to my YouTube channel. In this video, we are going to build an end-to-end machine learning project, or you can say an end-to-end machine learning case study. And this will be benefit, or this like the whole video will gonna benefited to those people who are beginner or 6 month or 1 year of experience. Why? Because in this video we are going to learn lots of things, like how to get the raw data itself and how to understand the data using some statistics, then how to clean the data and how to pre-process the whole data itself, then the data splitting into train, test and CV, whichever you want, and the vectorization technique, vectorizations like backup word, TF-IDF, word to vec kind of thing. Then how to build a machine learning model, like okay, after getting the whole vectorization thing, test vectorization or whatever that will be, how to build a model by using the vectorizer. Then we're gonna see the whole machine learning deployment, like how you're gonna save the model and you will put the model into the productionizations or what in the wave itself, and we're gonna see that. So, and we will discuss in the end, we will discuss the model improvement, how we can improve our model in future. So these are some of the things that we are going to learn in this video. And let me tell you one thing, the whole video I have done the whole coding step by step. I haven't skipped one of it. So just be sure, just take your laptop and sit down and just follow my step, and you are also going to build the same thing that I have built. Okay, and in this whole video I have used lots of library, and some of them are matplotlib, pandas, numpy, scikit-learn, and most like this is the most important thing, the FastAPI, where we have taken the model into and we have deployed into FastAPI. So in this video you are going to learn about lots of things. So just sit down and watch the whole video, or I would say just take your own laptop and do the coding with me. Okay, let me just create a folder and we will name the folder as sentiment classification. Okay, then what I'll do is I'll go here because now this is empty, but what we can do, we can just go to the Kaggle. Okay, and Kaggle IMDb sentiment analysis data. Okay, this is what we need for now. So this data is like there are 50k point or data point, we can say, in the data set, and we will use the data in order to classify the sentiment. So IMDb dataset having 50k movie reviews for natural language processing or text analytics, and as you can see the dataset is 63.14 MB. So we'll first download the whole data, and as you can see there are two columns here. We have column called review and another column called sentiment, and in the review column we have text, which is the review of people, like are people liking the movie Oz, and are people are liking the Mission Impossible, etc, etc. And we have the sentiment, like is this review is a positive or negative sentiment. Okay, so let's download the data, and okay, I have to sign in first. Okay, I just signed in, and now I can download the whole data. And if I just let me just download it in my folder. Okay, let me just download first, and I can move it to the sentiment classification folder. Okay, so just show in folder. Okay, now I will just cut this thing and we will go there, desktop, yeah, and sentiment classification I'll put here. Okay, here we have, and as you can see this is a zip file, so we can extract this thing. So extract here because we need that. And now that we have everything, we can just call our Jupyter notebook. And if you don't know about Jupyter notebook, Jupyter notebook is a from Anaconda. It's a tool that you can perform various kind of uh, machine learning things, like you can build models, you can analyze the whole data, and it's kind of great, you know. And you can download it, or like, let me just open it up, Jupyter notebook. Okay, I'm just started my command line, and there I just type the Jupyter notebook. So this looks something like this. Here you have a Jupyter, and we have the data, as you can see. So what I'll do is, if you don't know, like if you don't have Jupyter notebook, so you can do one thing: download Anaconda. Okay, you can do this thing, and you just go here, the first link, you just have to click this link, and yeah, here you have, and you can download the whole Anaconda thing. And after downloading the Anaconda thing, make sure that you have just click on the Jupyter notebook thing, because there are lots of things, like there is a spider and there is Jupyter notebook, etc, etc. So you have to click the Jupyter notebook. Okay, so, and there are lots of tutorials about Jupyter notebook, you can follow anyone. Okay, so let's just see the whole thing we have. Now I have the whole Jupyter notebook thing, so I can create a Python 3 notebook. So let me just create the Python 3 notebook. Okay, so here we have the Python 3 notebook, and what I can do is I can just name it as sentiment classification on IMDb dataset. Okay, this looks cool, and yeah, I don't know. Okay, so let's just mark down, and I will just put it here. So this looks great. And now what I'm gonna do is, like I have to give some information about the dataset and what is it. So I will just copy it from here. Okay, and I will paste it here. Okay, let me just copy and paste it, and what I'll do is, like, yeah, we have the binary classification things, because look, this dataset is for binary sentiment classification. So we're gonna do the binary classification thing. So this is it, and just shift enter. And now that we have the whole thing, I can do, like, now we have the data set, and we have open the Jupyter notebook. We can read the data. So I'm gonna read the data first. Before reading, what I'm gonna do, I will just call import the pandas function. So let's import pandas as pd. Okay, let's import pandas as pd, and yeah, we have the panda. Now I'm gonna create data equal to pd.read csv. Okay, there is a function from pandas to read csv. So here is the function called read csv, and here I will put the csv file that we have, and the csv file is imdb dataset csv.csv. Okay, so just I'll put there, and now I don't have to, like, I will run it, but just give me a moment. We'll call another function called data.head in order to see the whole data set. So head is basically, it will give I don't know, it's 5 or 10 line of from 10 data points, it will give something like that. So we have to run this thing, so in order to see the whole data set. And here you go. So if you just call this function, and just after calling the function, you just take the variable or object and call this function again, you will get 5 data points. And here is the data point, so the review and the sentiment is positive or negative, okay, based on the thing. So right now what I can do, we can do lots of stuff. For first, let's just do some basic stats, you know. It's good to done some basic stats. So I will just write down basic stats, you know, basic stats. Okay, so I'm gonna do basic stats. So first of all, from the, like, I just wanted to know how many rows we have and how many column we have. So I'm gonna print number of rows. Okay, number of rows. So what I'm gonna do for that, we'll call data, and there is a function called shape, and from shape we can give a square bracket and we can put 0 in order to see how many row we have, and again I will call the print function, and we're gonna see number of column we have, number of columns. Okay, number of columns, and I can call the function data dot shape, and here I can put 1. Okay, and if I just print it, okay, I just have to give the dot, and here we go. So number of rows is 50,000 and number of columns is 2, as you can see here. Next thing, what are you gonna do? Like let's get some information. So I can call a function data dot info. Okay, and calling these functions, what I'm gonna do is gonna give lots of things. First of all, the data we have, this thing, the data thing, it's a panda data frame. Okay, and the index we have, like the rows we have, is 50,000, and there is the ranges from 0 to 49,999. Okay, and the column we have 2 column. First is review, and the other one is sentiment. And do we have any null? No, we have 50,000 no null value and 50,000 no null sentiment and review. And what is the type of it? Type is object. Okay, the data type is object, and you can think object as a string, you know, that is fine. So we got the information. Now I wanted to know, like, okay, we have a sentiment column, so we have positive sentiment and negative sentiment. So let's see, is the sentiment, like the data we have, is a balanced or imbalanced, like the positive sentiment is equal to the negative sentiment or vice versa. Okay, so let's just say, okay, so for that what I'm gonna do is I'm gonna call the function data dot, okay, data dot what we have, sentiment dot value counts. Okay, this function is quite useful, you know. So you can call the value counts and it will give you the unique value of each sentiment. Okay, let's just print it or run it. Okay, so here we have negative, like we have 25,000 negative reviews and 25,000 negative reviews and 25,000 positive reviews. So we got a balanced data set, and which gonna do like really easy stuff, like we don't have to worry about the imbalanced data set. So that is a great thing, you know. So yeah, this is it. So the basic stats is that, and the basic stat is done. Looked onto some basic stat, we can jump onto data cleaning and reprocessing. So let me write down data cleaning and pre-processing. Okay, so okay, now what I'm gonna do is I will just look a single review. Let's say data review, and I will take one review, and we will see what are the things, you know, that we need to, let me just rerun all this then. Okay, what are the things that we need to clean up? We can look onto that. Okay, it will take some time, I guess. Yeah, so here is our review. The review is about some movie, obviously, because this is the IMDb dataset, and here there are several things that we need to clean. First, we need to clean some, like the HTML header thing, okay, HTML tag or kind of like that, and we need to clean the hyphen or slashes. Okay, here is the slash and here is the slash. So we need to clean all the slash, we need to clean the parenthesis, and yeah, this is the thing. And we need to convert whole thing into lowercase, capital letter or small letter, so we need to convert it into small letter. Okay, these are the things that we need to convert. So what I'm gonna do is, like, let me search how to remove, how to remove HTML tag, because let's say I'm a beginner and I don't know how I'm gonna remove this tag in Python. Okay, so let me just search this, and the one that I'm getting, like the first link, I will go here. Stack Overflow has every program. Like, you have any confusion or you don't know any code, you can jump onto Stack Overflow and learn from this. So here is the thing. So we can use a regex where we have to install the RE, which stand for regular expression, and we can use the re.compile, and we have to give this thing, like this whole thing, and we will get the clean data, which is we will provide the raw HTML and it will give us the clean data, like it will clean the HTML tags. And another way is to use Beautiful Soup. Okay, Beautiful Soup is a great library and we can use this thing as well, and this looks kind of little bit easier, and it's look okay because I don't have to care this much of code. I need to just do these things and it will gonna work. Okay, and the much more robust than the default one, HTML parser. Okay, we will look at it. Okay, let me just take this thing. Okay, let me just take this thing and I will put here. Okay, in this video I will show you how you can use different code into your problem. Okay, that is the whole purpose of this video. So I'm going to like take from VS4 import Beautiful Soup and what I'm gonna do is I will take the whole data, like I will take this whole sentence into a, like I will put into a object, let's say text. Okay, let me name it as text. So we have the text, and what I'm gonna do, like let me run it. Okay, and now if I just, yeah, we have the same thing, and now I can use the whole code. I can use the whole code. Let me just instead of raw HTML I will put the text. Okay, instead of raw HTML I will just put the text. Okay, and I will, let's just run this cell. Okay, what is the problem? Invalid syntax. Okay, from HTML.text, I think. Okay, what is the invalid text? From VS4 import. Okay, let's see. Okay, here is our problem, and from m. Okay, so now if I run it, what is the problem again? Let me just see. From. So if I just run this thing, okay, now as you can see here we have br, and here we don't have any br, which means we remove the HTML tags. Okay, so this is the first thing that we need to do, and don't forget to put the link, in, like, it is better to cite or refer to the author or the developer who provided this code to you. So it's a great it's a good learning. So this is the way you can put the whole thing, and let's see, are we missing something else? Are we missing something else? No, we are not missing anything. So okay, it's good to go. Next thing is to just remove, like how we can do some punctuation thing. Like there are lots of punctuations, and how we can remove punctuation, and let's just search the how to remove what punctuation. Okay, punctuation from a string Python. Okay, it will work. And best way to strip punctuation from a string. Okay, this is a good thing. So now I can use lots of things. Like here here there are from an efficiency perspective, you are not going to get this thing. Okay, this is great. For higher version of Python, you can use this thing. Okay, we will not use that. And I don't know, it's let me just pick one thing. Okay, there are lots of way you can just put your thing, and this looks pretty good, you know. From RE, that is also stand for regular expressions, and this is the whole part. This is the whole our sentence, and if we just provide this thing re dot sub r and the whole expression here, you will just remove the whole punctuation from a given sentence. So I will just take this whole, I will just take the whole code and I will put here. Okay, I'll put here, and let's see if it is working or not. And just let me just see first. Okay, string with punctuations, great, it's working. Now we don't need this string. Okay, and we don't need this thing as well, so I will write it as text or clean text. Okay, clean text. Okay, so now the clean text will be this thing, and we will remove the HTML tags. Okay, sorry, the punctuations thing. So instead of s, I will provide the whole clean text. Okay, let me just put here and let me print the whole thing. Okay, now as you can see, the whole punctuation, like the slashes, the exclamatory mark, and again slashes, all are gone. So in this way you can remove the punctuation thing, you know. And again I will put the whole link in my code. Okay, so here we go. Next thing what I'm going to do is I will do some of the stuff like I'm gonna use, like I'm gonna remove the whole stop words thing. And because there are lots of stop words, like what does mean by stop words, we will see. Okay, we will see what does it mean by stop words, and we will remove the whole stop words thing from the data itself. So what I'm gonna do is I will check. Okay, I will check what is Python stop words. Python stop words. Okay, we'll see here. So we can go here, we can go here. How to remove stop words using NLTK or Python. Okay, great. Let's just see Stack Overflow again. Okay, this is not okay. We can go to Geek for Geeks as well, because they also provide great code. Okay, so here we go. We have to import all these things, and let me just copy from here. Okay, and I will just paste here, and we will see what does mean by the stop words here. Okay, stop words means that is like, let me tell you what does mean by stop word. Stop word means the letter which are, or the word which are not very useful, like the is not a useful word, and you can say is also not a useful word for machine. For us it's a grammatically thing and like that, but from machine it's not a useful thing, it's a useless thing. So in order to remove, that thing, Python has a list of stop words, and I don't know what is it, and it's okay. Okay, we have to download the NLTK thing. Okay, let me download this. Okay, so we have to download, import NLTK and import NLTK stop words. We have to download the stop words. Okay, you have to remember all these things. And yeah, here we go. So these are my stop words, like I, me, myself, we, our, ours, ourselves, you, you are, you have, you will, up, from, down, in, out, and all these are stop words, and we have to remove from our text. So that, like, first of all, there are two reasons it is not like useful for machines, and second thing is the text you have will be minimal little bit. So this is the thing. So let me, how we can remove the all things, let me just see. Okay, so what we can do is how they have done, like in this video you're gonna also learn how you can learn from others code as well. So what they have done, they have put the whole stop words thing in a set. Okay, then what they have done is word tokenize sample examples, and okay, so they are tokenizing the whole thing. Okay, we don't have to do this, the tokenization thing. Okay, then what they have done, they have, like, how I'm gonna read this thing. Okay, let's just read the thing. For w in word token, okay, so it will take all the tokens, and if if not w dot lower in stop words, okay, if w the tokens is not in the stop words, please provide me the w. That is the whole sentence, or that is the whole code. Okay, so then what they have done is they have just simply append it here. So that's it. So we can use this thing, but I will not use the whole code, and let me write my code. So what I can do is, first we will need the token thing. No, we will need the token thing. So I will write clean. Okay, I can write token is equal to clean text dot split. Okay, what it will give you, like, let me just print it. Okay, look at this. It will give you a list of words, like here is like here lots of things, like it's splitted into like wonderful little productions, the filming, like that. So yeah, it's a good way to write the whole thing, and okay, let me just do the whole thing. And we have the tokens, and next thing is we have to, like, we got the token. Next thing is we have to check whether it is in stop word or not. Is a is a stop word or not, like that. Okay, so another thing, as you can see here, like here all of my stop words are in lowercase, and here we have like the uppercase here, and like that. So we need to convert it into lower thing. So what I'm gonna do is I'm just use the whole thing, like, let me just create a list. Okay, so I will create a token list. Okay, empty token list, which we will append our whole thing. And for I in token, for tokens, let me just put this name tokens. Okay, so for token in tokens, if I not in stop word, which is this thing, I guess. So I have to keep this in a set and name it as stop word. Okay, so I have to name it as stop word. Okay, so stop word. So I don't know what's gone wrong, and let me just copy this again. Okay, and paste it here. Okay, so stop words. Okay, and we will have to provide a set. Why a set? Because it will just take only unique value. Okay, so that's why they are giving text. So stop word. Okay, stop word. Okay, if I not in stop word, okay, not in stop word, I will append token. Okay, spelling mistake again. Token. Okay, token list dot append what I. Okay, now we will see what's going on. Okay, let's just see. Okay, I haven't provided. Okay, I. Okay, great. Again, no. Okay, token. So here we go. If I just now print the token list, okay, token list, it should. Okay, there is one thing we are missing here. If if token dot the thing is not, we have to lower the whole thing. We have to lower the whole thing. Like, yeah, we have to do that. So let me just do one thing, because it's not recognizing this thing. So let me just token Okay, let me just clean text equal to clean text dot lawyer. Okay, we'll call these functions, and now hopefully, yeah, we got our cleaned like it's remove all the stop words right now. Like wonderful is there, but a is not there, and there are lots of, like, you can't find the stop words. Okay, so yeah, we got this thing, and now I will just delete this thing. Okay, because I don't want to put here. It's taking my lots of screen. So yeah, so next thing what I can do, or what we can do, is we have to, like, there are things, in machine learning or in basic cleaning, that you have to lematize the whole thing. Like, what does mean by lemmatization? Lemmatization means, like, if we have a word, okay, we have to take the base word. Like, let me just say, we can say run and running. If you find anywhere running, you just put to run. That's it. So lemmatization means taking a word and bring it onto their dictionary word or root word. Lemmatization means just convert it into, if you find any word, convert it into its base word. So how I'm gonna do lemmatization is, I will just search here. Okay, I think lemmatization and stemming example, we can just search it, and we can find here. Okay, we can find here, I guess we'll find here. So there are 2-3 things, like there are 2-4 stemmer out there, one is a lemmatization and another is stemming. So stemming is just what it doesn't give you the dictionary root word. It will give you any, like, it will give you a root word, but it not necessarily the dictionary root word. That's the idea that stemmer is have. But the lemmatization, the lemma of a word means the dictionary root word. That is, so this is the difference between stemming and lemmatization. Okay, so let me just take the lemmatization. Where is the lematizations? Okay, here we have the lemmatization. So what I'm gonna do is, from intlk.stem import wordnet lematizer. Okay, we're gonna do that. So yeah, it's working. Now what I'm gonna do is, I will call the whole function, the lematizer thing. Okay, let me just call it. Okay, it is working. And now what I'm going to do is, I will call the lemmatizer for every word that I have. So I can do one thing. I can call for token. Okay, for token in what one thing we can do here, I can call join. I can call join. Okay, let me just do, and let's see, is it working or not. I don't know it's going to work or not. So let me just take this thing. Okay, no, it's okay. We have to put here. Okay, what's happened? But join the token, it should work, no? Okay, let's just take it as this. I don't know why it's not working. Okay, so here we go, and I can take for token in token list. I'm calling this thing, this object, and what I'm going to do is, for every word it will give me the lemma word. Okay, so lemma word, it will give me a lemma word. So I will just take this and I will just call this thing lemmatizer. So lemmatizer dot lemmatize. Okay, there is a function called lemmatize, and I will provide the token. Okay, I will prove token. So yeah, and if I just print this thing, okay, if I just print this thing, it will give me the lemma word of every what I have to download again. Oh god, this is bad. Okay, so I need to download again and again and again. So lemma, we have to download the lemma of every word in English. Okay, yeah, we are done, I guess. Okay, it's true. What lemmatizer? Okay, I have to append it. Lemma word dot append. Okay, what happening? Okay, lemma word dot append, and lemmatizer, I guess. Lemmatizer. Okay, that's it. Yeah, we have the lemmatized word. You can see, like, let me just provide an example so that you convinced that it is working. So let me just put let me just give what I guess running. No, not running is not the right word. Writing. Why it is not providing? Okay, let's just see. Yeah, books. We can take books. Okay, yeah, it's it's giving us book. So I hope you are convinced that it is working. So we what we have done till now, let me just take you. So we first see the whole text, then we clean up the whole HTML tags thing, then we clean the punctuation, then we remove the stop words, and then we lemmatize our text. Okay, this is the whole process till now. Next thing what we can do is we can just we can join whole thing, because we have a list and we can join our whole list because as you can see, this is not looking like a sentence. So what I can do is I can just join all these things so that it looks like a sentence. So for that, what I can do is I can say dot join. Okay, and what we have is the lemma word. Okay, I can provide the lemma word, and let's call me join text. Okay, and if I just print join text, hopefully, yeah, so we have our the whole sentence, or we have our whole sentence with, like, here you can see there are no stop words, there are no HTML tags, there are no punctuations, and whole thing is reduced, or the whole words are in the form of their lemma. Okay, so we are almost done with the cleaning, and the next thing what we can do is now we just take a single text or single review, and we have done all these things. Now we can create a function so that the function can take the whole data set and it will clean it up like the way we have did in just like this. Okay, so what I'm gonna do is I'm just create a function. Okay, I'm create a function. Let me call that function data cleaner. Okay, data cleaner. Okay, and in the data cleaner, I don't know what should we provide. We will provide sentence. Okay, we'll provide the whole sentence, and sentence or data, I don't know. We'll provide the text or data. Okay, we will provide the data, and for the data what I'm going to do is like for sentence in data, for sentence in each data, okay, for sentence in each data, what we're gonna do is we will use the beautiful soup. So this is the beautiful soup. Where is the beautiful soup? We will use this thing. Okay, we will use the beautiful soup. Next, what we're gonna do, we will use the stop word removal thing, the punctuation thing. So where is the punctuation thing? This is the punctuation thing. We will use the punctuation thing. Okay, now yeah, we are providing this thing correctly. Okay, next thing what we're gonna do is we will use the stop words thing. Okay, the stop words thing, this whole thing, and instead of writing like the bulky code, what I can do is I can let me just show you how we can write the whole thing. I can say for token in stop word, okay, if token not in, for token in stop word, if token not in what, not in stop word, stop, for token in tokens, I guess, for token in tokens, because we have, because from tokens it will give us token. So if token not in stop words, okay, what I'm gonna do, what we will do, token, first we have to lower the whole thing, you know, I have to lower, so we have to provide a token with lowercase. Okay, so, and I will give here a square bracket. So now if I can just take the token list, I can use this one. Okay, that's great. We just wrote the whole thing. We just wrote whole thing into a small thing, and there are still some missing thing because we splitted the whole tokens thing. So I will do the split here. I will do the splits here. So for token in tokens dot split, okay, we will get the token. If token not in stop word, please provide the token with lowercase. Okay, with lowercase. This is the whole thing, and if I just run it here, okay, let's just run it. Hopefully we'll get the whole thing. Okay, split list object has no attribute split. Okay, so what I'm going to do is, so I can just call the clean text, I guess. So I can just let me rerun the whole thing. Okay, let me just rerun the whole thing, and token in clean text. Okay, hopefully, so it is not removing it. So for token in clean text stop, if token not in stop words, if token not in stop word, then lower it, and it is not working. Why? So what we can do is, instead of calling this lower thing here, I can call this here. Okay, and it should work, you know. Let's just see. Yeah, it's working. So we can just take the whole thing, we can take the whole code, and we can put here. Okay, we can put here, and we can put the plain text again, because I don't want to name lots of names, so I don't want to. So just here we go. So we just use the beautiful soap, which is used for removing HTML tags. Okay, next thing, remove punctuation, I guess, and stop word, stop word. Okay, stop word. And next thing, we will use the lemmatization. Lemma. So the lemmatization also, what we how we can write is, I can write is for token in token list or token in token list. For token in token list, what I'm going to do is I will use the whole thing. Okay, I'll use the whole thing. Okay, and we'll put a square bracket. Okay, now just look at this. I'll put here, but there is some changes we need to make. There is some changes we need to do. And for token in clean text, it should be in clean text, and I will again name it as clean text. Okay, clean text equal to lemmatizer blah blah blah. Okay, great. Now in the end what we can do is we can just join the whole thing. We can just join the whole thing join. We can call this function. Okay, we can call this function, and here we go. And now I will strip, like I will again call a function called strip, which is just basically remove the extra space from a given sentence. So I will do the strip. So instead of, like, now we have to store the whole clean text in somewhere. So I will store the whole clean text in a clean text or clean data. Okay, I will store the clean data here in a list, and I will provide the whole thing. Like, let me just call this thing. So clean data dot append. What we're gonna append? We're gonna append clean text, but we will use the strip. Okay, we will use the strip so that it remove all the extra space. Okay, so strip function. Okay, there we go. And I can just say return me the clean data. Okay, return me the clean data. And yeah, we are done with this function. And let me just call this function. Okay, let me just call this function clean data. Okay, and I will just take the whole function, and let me see what is the name of my data frame. I guess data. Okay, let me just again call this so that we have the data. And okay, here we go. And another thing, I don't know it is working or not, or how I do know the progress. So I can do one thing, tqdm. Okay, so that I know the progress. Okay, so I'm going to do import not import, from tqdm import tqdm. It's just to know the progression, you know. So is it working or not? Why it's just stuck there? For sentence in tqdm it should work. Where is this missing? I don't know. What happened? Okay, here we have to give the sentence. Okay, here we have to give the sentence. Let me just check again. Okay, we have given the sentence, and let's see. No, again it's not working. And what happened? Clean text. Yeah, we have given clean text. Clean text is lower if not in stop words. Lemmatize token dot clean text. Okay, yes, we are again taking this clean text for token in clean text, and it should work, I guess. Let me just take dot text and just not text, we have reviews, I guess. Review or reviews, I don't remember exactly. It's review. So review dot values. Yeah, it's working, and it will take some time because I don't know, my computer is slow, I guess. So it will take some time, and till completion I will just pause my video, and after the completion I will get back onto this. Okay, so it is completed. Now we can see the whole thing. Like, let me just see my first clean text, and okay, here we go. And it has lots of things, like not only this point, it have like it maybe have like 100 short film inspired stunt show, full length feature, blah blah blah, and I don't know what that does mean. But there is one thing that like, now we have cleaned all these things, and it is always better to clean the whole thing. But from my point of view, we should not like in data science, in machine learning, there is a term called train data and test data. So what does that mean? So if you say train data means the data which we can use for our cleanness and all those things, and for modeling and for training, etc, etc. But we should not touch the test data, which should be for the testing purpose, So what I'm going to do is, it is just the whole thing that I have done here is just for, like, in order to know, okay, all these things are working correctly. But what I'm going to do here is I will just break the whole data into two parts. One part will be train data and another part will be test data. So let's just break the whole thing by using something called train test split. Okay, I will show you what does that mean. So I will take the train, I will write the train test split from sklearn. We will use that thing. Okay, so sklearn model selection train test split. Okay, we will use this thing. Okay, so here we go. So here we have a function called train test split, and I will not go into this whole thing. We will first see the example, and after that we will see what are the parameters that we need to provide in order to get the train test split. Okay, so here is an example. It's saying that we can provide, like, it will give you 4 output, like x train, x test, y train, and y test, and you have to provide the x is the x is the data that you want to train, and y is the target that you want to achieve, and test size is 0.33. That means the whole train data will be 77%, and the test data will be 33% of the whole data. And random state equal to 42. That means that every time you will run the whole thing, you will get the same output. You will get every time the same x train, x test, y train, and y test. That is the whole purpose, of this whole parameter. So what I'm going to do is I will copy the whole model selection thing. I can write it as well, but also here I will give a name, and I will give a name train test split. Okay, so yeah, here we go. And I will import the whole model selection dot sklearn model selection import train test split. Okay, I will import the whole library, and I can call this thing. Okay, I can call this thing, and yeah, we have to make some changes here. First, we don't have any x, we have data. Okay, we don't have any y, we have something called data dot sentiment. Okay, and in the test size I will give is 0.2%. I don't want more than, like, I want to train 80% of my data, and random state will be 42. And another thing, there is another thing in the train test bit called stratified. Okay, stratify. So what stratify is, it's a sampling technique. Let me just search it. Okay, stratify. Okay, stratify. You're gonna learn, you're gonna know how it's going to work. Okay. So let me just see. Stratify sampling, is it the right thing? No. Let me just see which is the best example. Yeah, so this is the best example. Okay, I think, in order to understand what's going on here. So let's say we have this, let's say we have the whole data set like this, and we want to sample 3 point out of this. Okay, we have the whole data and we want to sample 3 points out of this. And or you can say there are 3 kind of people. Okay, one is neutral, one is whatever that is, and we want to sample this out. So if I just randomly sample, then this 3 I may get these 3 people only. I may not get the whole white people and the red people, red faces. I may not get. Okay, so instead of random sampling, what we're gonna do, we're gonna do stratify sampling. So what does stratify sampling does is, it will take you, or it will bring, like, the white face, the red face and the green face. So it makes sure that from every portion it have some sample, from every portion it have some sample. So stratify sampling works like this. So I hope you got the whole idea of stratify. So I will take this thing, stratify, and what is the output? Okay, like, or okay, I will give the stratify. Okay, so I will give the stratify, and instead of none I will give the out target thing. Okay, and now if I just run this whole thing, so let me just print the whole thing. Print, okay, print xtrain. Okay, print xtrain dot shape and ytrain dot shape, and let me just print xtest dot shape and ytest dot shape. Let me just print it. Okay, we got it. So we have our the whole sampling thing. Now what I can do is, I can provide the whole data onto into our the data cleaner function. So we will call this thing. Okay, we'll call this thing, and I will say for train data cleaner data for train data. Okay, and instead of xtrain I will give instead of data I will give xtrain, and yeah, it will work, and it will take me some time, like around 1.5 minutes. So I will, when it's complete, I will be there. Okay, so it is done. So what I can do is, like, I can put the whole clean text into, like, creating a new column called clean text, and I can put there. So I can just call this, and yeah, and now I want to see the whole thing. Train dot head. Okay, let's just see what happened. I don't know. Okay, I have to reset all those things, you know. So yeah, okay, that's fine. I scanned. Okay, so if you want to just remove the whole red part, what you can do is, you can call a function called reset index equal to reset index in parentheses just drop equal to 2, and you will get, you won't get this whole red part. So yeah, it's working. So if you can see, like, it's like, look, the star mark is gone, and the exclamation mark is also gone, and yeah, we got the clean text. Okay, so it is working. And now what I can do, instead of x for we can do for x test as well, x test. So before that we have to do the cleaning thing. Sorry, so we have to do the cleaning thing, and instead of train I will put here test, and I will again take the whole data, like the code, and instead of x train I will put x test. Okay, and it will take 20 seconds, I guess, hopefully, and then we will call this thing. Okay, and instead of x train we will have x test, and yeah, again it will give us some warning. Okay, so don't worry about that. Okay, here we go. So we can just do the reset index kind of thing, so don't worry. I can show you, if like I can just x train equal to x train dot reset index drop equal to true. If I just do that, yeah, we got this thing. And we can do the same for x test as well. So x test and x test. Okay, here we go. Yes, MTV, there is really is a way to market, blah blah blah. So okay, congratulations, you have also done the whole thing of cleaning. It don't, like, let me say one thing. It is the basic clean that every data scientist or every machine learning engineer, or who they are learning, or every enthusiast student should know this basic cleaning thing, so that you can clean your data and you can feed any machine learning model you want. That's the whole thing. And why cleaning is important, because we don't want our machine learning model to learn weird thing, because it can't, and you will not get the desired result that you want. Okay, so next, the big thing is the vectorization. Like, what does mean? Let me tell you what does mean by vectorization. So vectorization means, like, here we have sentences, in English, but do our machine or do our computer gonna read it? No, it can't read this thing. So in order to provide to our machine learning model, we need to convert the whole thing into vector. We need to convert the whole sentence to vector, and for that I'm gonna use two kind of method or two kind of technique. One is called bag of word and another is called TF-IDF. I have two video on this. Okay, I should not do this. Okay, let me just open a new tab. Okay, I have a video, okay, called bag of word. You can see the whole thing, the whole intuition behind bag of word, how bag of word work and how that thing. Okay, it's natural language. I want bag of word. Okay, I want bag of word. Yeah. So okay, so it's in Hindi, so I hope you know Hindi, and it's a detailed explanation about bag of word, how bag of word work, and you can also access to my TF-IDF thing, so which is also I have explained in great detail. So I hope you like it, because I made this video, like, it's quite useful video. You should see this. So okay, no further, like, I will not again go to all those things, and let me just, is it working or not? Let me just say. So now what I'm going to do is I will use bag of word, which is called count vectorizer, and the TF-IDF. So let's see how we're gonna use it. So what I'm going to do, so I hope you understand Stratify. So here we go, count vectorizer from sklearn. So we will use this thing. So yeah, this is the whole, don't scare of this whole thing, because believe me, this whole libraries is a lifesaver for data scientists, you know. So there are lots of things. So I will take this example. So here is the example. Let's understand the whole example, then we will use this whole example to our problem. Okay, so here we go. sklearn feature extraction the text, import vectorizer. This is the whole library you want. Let's say this is a sentence, and what we're gonna do, we're gonna vectorizer, we're gonna call the count vectorizer function. Okay, after calling this function, what I'm going to do, I'm going to fit transform the whole corpus. Okay, I'm going to fit transform the whole corpus, and yeah, and if you right now print the whole text or print the whole x, you will get a vector. Okay, so this is the way we can do. We can use the n-gram also, where we have to like there are three things, 1 gram, 2 gram, 3 gram, n-gram, like that. So for 1 gram it will take only one word. For 2 gram it will take this is the first document. It will take like this. And if it is 1 gram, if it is 3 gram, then it will take this is the first document. It will take like this. So that's extension of the whole count vectorizer. So what I'm going to do is I will just take the whole thing and I will put here, obviously, and in the end we will just put everything into what we'll put everything, the whole library on a top, where we have like here, let me show you here. Okay, we will provide every library we have used till now, we will provide here. Okay, so don't worry. So let me just run this thing, and I will call the whole vector account vectorizer thing. So I will create a vectorizer vec, and what is count vectorizer, and it's a function, remember, because this is a class, and we have to call the class, and we have to create a object. And I will say vec equal to vec dot fit. I will fit our whole data. I will fit the xstring here. So I will fit xstring dot cleaned text. Okay, the whole clean text. I will fit this thing, and now I will use the vector to use in a lot of way. So I will say train x bag of word equal to vec dot transform this whole thing, because I want to transform it. You can call the fit transform as well. Next is text x bow, and here we go. Okay, it will take some time, and I hope we'll get soon. It won't take much time. So so let me just write and just write down the shape of it, so, or print out the shape of it. Remember, the bag of word and tf-idf, these vector are very sparse. Sparse means you will get lots of zero in there. So the bag of word and count vector is put some sparse vector. So you need to give this vectorizer into those kind of model which takes sparse and work well on sparse vector. Okay, so let me just take xtrain dot shape. Okay, and print test x bow dot shape. Okay, here you go. And as you can see, it's a quite big dimension, like for 40,000 points, and you have for each point you have what is it is 100, 600, this is 1000, 1600, this is 81,000, it is 1,81,688 dimensional vector you have. So that is why I'm like saying that you will get a sparse vector. Now we got the vectorizer thing. So I can create a cell here and I can name it as vectorizer. Okay, I can name it as vectorizer. Okay, and now the next step, now we have converted our text into vector. We can feed it our machine learning model, and this is the really this is the most enjoyable thing, because in machine learning, the model is not a big thing. The big thing is how you're gonna preprocess the whole thing, how you're gonna clean the whole text, and all these things are important, and how you're gonna do the business problem, that is important, not the model. Remember that, because you can create model, because like there are lots of library providing us the whole modeling thing. So we will jump next to the machine learning model. Okay, so we have to find some algorithm or some model which is very good on using the sparse vector, and we have some model called, one is naive Bayes, which is best for high dimension, and another is logistic regression. So we will use these two model in order to get the result or get the output. So let's just see how we can use the naive Bayes, and next thing is our logistic regression. So let me just remove all those cells on tab actually. So I can say naive Bayes. Okay, naive Bayes sklearn. Okay, so we're gonna use multinomial naive Bayes. We can use Gaussian naive Bayes as well, but yeah. So here, one thing that you need to remember, the hyperparameter. Okay, that is the most important thing in the naive Bayes. So we can read this thing. Naive Bayes classifier for multinomial models. The multinomial naive Bayes classifier is suitable for classification with discrete feature. Discrete means that are like binary or multiclass classification, like that. Okay. The multinomial distribution normally requires integer features counts. However, in practice, fractions count such as TF-IDF may also work. Okay, remember that thing. So it may work the TF-IDF as well. Okay, next, so we have to provide the alpha. Alpha is the hyperparameter, and we have to do the hyperparameter tuning in order to get the best alpha. So let me just take the whole sklearn, because this is the example. From this example, we will use this example, you know. So let me just take from sklearn, import naive Bayes. Okay, and we will import this thing, and I will name it as naive Bayes, naive Bayes with hyperparameter tuning. Okay, naive Bayes with hyperparameter tuning. And okay, let me just the next thing is we have to call, like I will call classifier. Okay, I will call classifier, and I will call this class. Okay, I will call this class. Okay, here we go. We have called the class, and now what I can do is I can just fit the whole thing. Here we go. I can fit the whole thing, but before that we have to search the hyperparameter. So what I'm going to do is I will do one thing, like I will say, because we have the alpha, so I will take alpha ranges. Okay, I can put alpha. So I will create a dictionary, okay, and I will give alpha. Alpha will range from, okay, alpha will range from, let's give some like 10 to the power what, 10 to the power minus 2, and next thing 10 to the power minus 1, and 10 to the power 0, which is obviously 1, and 10 to the power 1, and 10 to the power 2, 10 to the power 2. Okay, this is the what, the alpha thing. Okay, so we will use this thing, and what I'm going to do is I will instead of this, yeah, we can use this thing. Okay, just we will use this thing. So next thing is how, like, what exactly it will do is, for alpha is 10 to the power minus 2, it will take our x string and it will try to fit onto multinomial neighbors, and if it will give you a score, then it will take 10 to the power minus 1, it will fit the multinomial neighbors with our x string and it will give you a score. Like that, it will give score for 10 to the power minus 2, 10 to the power minus 1, 10 to the power 0, 10 to the power 1, 10 to the power 2, and we will compare all that score, and after getting all the score, which will be the best score, we will take that. Okay, that is the whole thing. And for this thing, we have to provide the whole thing in a search thing, you know, we have to provide it in a search, so that it will search for every number or every alpha value and it will give us a number. So for that, we have two kind of search. One is grid search, another is random search. So I will use the grid search. So let me just do let me just call that function, and actually we have to call that function. So let me just grid search CV. Okay, it's come from, it's under model selection. Okay, so how we can use this thing? Okay, here we go. Always best to see the example, you know, to get some idea how you can use. So we have this thing, and now, okay, so grid search, you have to put the SVS, which is your classifier, and some parameters, which is our, in parameter what we have, hyperparameter, we have the alpha. So I have to provide these two things and we are good to go. So let me just see. So we have to put the estimator, parameter, grid, scoring, which score we want to use. And let me tell you one thing for scoring. We can use lots of score, like we can use accuracy, we can use AUC, we can use not confusable, log loss, and like that. So as we have balanced data, we don't have any imbalanced data, so we have the balanced data. I will use score as our accuracy. I will try to test the whole accuracy thing. Remember, if you don't have accuracy, like if you have if you don't have balanced data, you should not use accuracy. You should use accuracy when you have balanced data. So I will use accuracy because we have balanced data. How do I know we have balanced data? Because here in the stats, you know, in the stats, where is it? Look, the negative points we have 25,000, positive points also 25,000. So from that I got I got to know that we have balanced data. Okay, so that's it, and let's write the code. So I will do cross. This is called cross validation also. Not cross validation, is let me just grid search, and I will prove grid search CV. Okay, and here I will first provide the classifier. Next, I will provide the parameter grid. Param grid equal to alpha what ranges. Okay. Next, I will use scoring. Scoring is obviously accuracy. Okay. And next thing is, what is the cross validation score, I guess. So here is the CV. It's important, you know, how many times you want to cross validate. I hope you know what does mean by cross validation, because I don't want to go too much depth onto it. So I will use CV. Okay, I will use CV equal to, let's say, 3, because I don't want to. And another thing, I want to return train score, because it's important for me in order to get the whole idea of it. And let's just see classifier. Okay, so classifier dot fit the train data, I guess. So here is the X train bow and Y train. Okay, how? Okay, what is it? Okay, it is giving us some weird thing. It should. Okay, sorry, I'm so sorry, it's my mistake. We have to prove the pictures. And what is the problem here? Invalid parameter alpha for estimator maximum link bias. I guess it's not invalid parameter, I guess. So alpha is the thing. I don't know, alpha ranges. Okay, again. Okay, invalid parameter alpha. Oh, sorry, I just alpha. Okay, don't, like, here I have just why, like, I don't know, every time I just do some wrong thing. Okay, so we got the best score. Like right now, then what we can do is I can just search for the best. I can just search for the best alpha. Or another thing, we can see the whole thing, you know, we can see the whole whole pipeline or something. So let me just do one thing. So I want to do, like, I want to know what is the alpha value, like for alpha is equal to 10 to the power minus 2, what is the accuracy, and for alpha is equal to 10 to the power minus 1, what is the accuracy. I want to know, and for that I want to do a validation score. So I will use like how to get validation score, you know, how to get validation score. Yeah, this is what I want. And there is a validation. I want to get the validation curve. Okay, and there is a quite good tutorial that I have gone through from, I think, from Git for Geeks. Yeah, this is it, I think, hopefully. So yeah, this is what we want. And what I can do here is, let's see what they have used. So they have used mean train score and standard train score. They have used mean test score and like that. So what I can do is, I can use all these things, like the mean train and standard thing, and yeah, we can do this. So let me, okay, we will use this thing, you know, we'll use this thing. So, and again, let me search from the, okay, how I can get the whole thing. Okay, so here we have mean test score and mean train score, and where we will get this thing will be implemented CV results. Okay, from CV results we can get all those things. Okay, so let me just take this thing. So train accuracy equal to, I think we have grid search. Okay, grid search dot cv results. Okay, and here I will provide the mean trend score. Where is the mean trend score? Because here they are providing the mean trend score, so I will provide the mean trend score. Okay, next I will just copy paste it. I'll just, because we have, so train accuracy, train, what is the next thing? Standard deviation. Okay, next thing we will need standard deviation, so I will use this thing for standard deviation. Okay, great. Now we will use for test, and we will use for test. Okay, test std, and instead of train I'll use test, and I will take this and I'll just replace it with test. And next thing, we will need the range, because it will not work here, so we will have to put here something alpha equal to this thing. Okay, let's just do this whole thing. Yeah, it will give us, just stay with me, we will get there. Okay, we will got the whole thing, like we will get this kind of curve. Okay, so now what I can do is I can copy the whole thing, and thanks to Geek for Geeks again, I will put here. Okay, I'll just put here, and I will give the alpha and the mean trend score, which is train accuracy. Okay, and this, and here I have to give the alpha again, and mean test score. Okay, and I just put red and green. Okay, I will put red here. Okay, let's see. PLT. Okay, we have to import matplotlib. Import matplotlib dot pyplot as PLT. Okay, pyplot as PLT. Hopefully it will work. Okay, let's just see. I don't know if it's going to work or not, and I have to change. Okay, here we go, it's working, and I don't want to name the name bias. Okay, naive bias. Yeah, it is working, and as you can see, look at this thing. This is the cross validations, and this is the train score, and at this point, I don't know, it's maybe 10, I guess it's 10 for alpha, and I have to give this thing alpha. Yeah, I have to give the alpha. So for the alpha equal to 10, we have the best score. You know, you can think, look Jitendra, this is also best, but remember, we may get onto underfitting, you know, so that is the one thing we should remember. This is the whole overfitting part, and this is the whole underfitting part, so we have to take a middle path. So that's it. So we will take as alpha is equal to 10, and let's see, there is another parameter. I will first, let me provide the whole thing, because these guys are great. They given us the whole thing. Okay, so let me provide another thing, like we can use this thing. Okay, so let me just take the grid search. Okay, dot best, I don't know, I just don't know exact name. Let me just search it. Yeah, best estimator. Okay, I will just call this thing, and we will get the best estimator. Simple. Okay, here you go. Alpha is equal to 1 is the best estimator, and now we can fit the whole thing on our multinomial name bias. So I can say classifier is equal to the multinomial name bias, and I will provide alpha equal to 1 because we have 1, and I can fit my whole data dot fit, and I can provide the train data. Okay, so let me just provide the train data, and train X bow and Y train. Yeah, that's it. Okay, so we have just fitted the whole thing, and now I can use the predict. So I can use the predict thing. Let me just predict. We can now predict our test data. So predict, and that I will call the classifier dot predict. What we have the whole thing. I don't know. Sentiment is what? Positive and negative. Did I just one thing that I'm missing, I guess. I don't know. Okay, just let me just one thing I'm missing here, because is it okay? We have to encode the whole thing. No, I haven't encoded yet. So one thing we have to do here, we have to encode the whole thing. So let me do one thing. Okay, let me just do one thing. Xtrain label encoder, we can call the label encoder from sklearn dot model selection, I guess, import from sklearn dot model selection dot pre-processing import label encoder. I guess it is, I don't know, from sklearn dot pre-processing. Does it? Yeah. Okay, so this is from sklearn dot pre-processing. Okay, now what I can do, let me first call the label encoder. Okay, label encoder, and then what we can do is xtrain dot what loc lock, and I can provide here the target. Okay, the target, and which is will be our le dot fit transform, and now we have to provide the whole thing, xtrain dot sentiment. Sorry, we have the sentiment, and again sentiment. Okay, sentiment, not okay, it's sentiment. Okay, so here you go, and hopefully it will work. I don't know, sentiment. Okay, don't we have any sentiment? Instead of, like, I can do one thing, white train, just do it for white train. Okay, if I just do white train, yeah, here we go. Okay, so for positive we have 1, for negative we have 0. That's it. Also for we got for white train. Now I can do like le.1 and le.1, and I can do for white test, and here we go. White test. yeah, it's working. Now I can do the whole thing, and okay, I don't have to do like from the beginning itself. I can just run this thing. Okay, we have got the same thing. And in prediction, what I have to provide is the white test, and the white test is what we like. I have to provide the white test, and let me just see what is that name. I don't remember, so I will just take it from here, and I will put here, yeah, prediction. And now that we have got the whole prediction thing, now we can see the whole now we can see the accuracy, how much accuracy we are getting. So what I'm going to do is I will call a function from sklearn dot metric import accuracy score, and I will just accuracy score, and here we have to provide the prediction, and we have to provide the white test and the prediction, and I can just print it, print. I will accuracy is okay. Let's just see what is the accuracy we are getting. Hopefully metric from sklearn metric, no module name metric. Let's see sklearn accuracy score. I hope metrics. Okay, metrics. Now, yeah, we are getting accuracy is like 85% accuracy. We are getting, like, not accuracy, actually it is 86% like accuracy we are getting. And there is another metric called classification report. I just wanted to show you. Okay, classification report from sklearn. It's a good report where it will give you the precision recall, F1 score, and something called support. So it's a really good metric, so let me use that. Okay, so from sklearn metric, classification report, etc., so I will use this thing, and again what I'll do is I will just copy this thing, and instead of accuracy score I will put the classification report, and it will give me the precision and recall. So look at this, the precision is 87%, recall is 86, and 84, and 86, and it is quite good. It's quite good. And let me do one thing, that we should know it is working or not. So we can say I can take the classifier, and let me say one thing, it is working or not. Let me just say let me just say the movie was great. That movie was great. Let me just take that thing. Okay, that movie was great, and let's say this is our text. Okay, that movie was great, not great. Okay, great. Okay, so here is our text. Now I'll do classifier dot predict text. We have to convert it into a vector first, so I will do like text vec, and I will put it into I will put it in a text. So vec dot transform transform, because we have the transformed vector from the count vectorizer. Where is the count vectorizer? Here. From this thing we can use this thing vector, and I will put the text here. Okay, and I will use the text back here, and let's see what is the predict. Okay, it is 1. And what does 1 mean? Let's say we have to do the level encoding, encode. Okay, is it encode or el? I don't remember exactly. Le, level encoder, le. So le, so le dot inverse transform, and I will put this array, I'll put this array here, and no, I will put only one. I don't know it's going to work or not. I have to put on this. I guess it's working. Okay, so positive. So it's saying that it's a positive review. That's great. And let me tell you one thing. This is the inference time. I'm doing the inference thing. So this is it. We are just converting the text into a vector, and we are providing to our classifier. Let me take another. The movie was bad. The movie was bad. That movie was bad, and let me just instead of let me just do the whole thing. Okay, run it. It's 0, and editor inverse. Okay, we have to provide 0 here, and here you go, negative. So congratulations, you have just done the whole cleaning thing and modeling thing, and now you have done the whole the inference thing. Now we will deploy the whole algorithms. We will deploy the whole machine learning model into the FastAPI thing. Okay, so what I'm going to do, I will use the VS Code, and I will use the whole code from here, and we will use the whole thing, just code part, and I will put there. Actually, I won't put everything. I will just put this thing, this thing, and we will use the FastAPI to deploy our model into web. That's it. Okay, so let's just jump to the VS Code. So till now, what we have done is we have just created a model using naive Bayes, and now we want to deploy our model into production. For that, what I'm going to do is I will just save our vector. Vector means the count vectorizer. We will save the count vectorizer, and we will save the model, which is our classifier here, this thing. So we will save these two things, and then we will jump to the whole deployment thing, so where we can use the FastAPI to deploy our model. So let me just call a library called joblib. So I can write from joblib import from joblib import load, and another one is dump, so that we can, now we just want to dump our model, so I don't need any other functions. So I can write like dump. I want to dump my vector, which is in the name of VEC. We will remember, because we are fitted the whole clean text in the VEC, which is vec. So we will save this vector where and then we can transform easily like that, like we have done here. So then we will transform the whole vector thing in the model itself. So let me just save this thing, vec, and I will name it as vectors dot joblib. Okay, and next thing is dump, and I want to dump the classifier here, this classifier, because we have created the whole hyperparameter thing. So I will just classifier, and here I will just dump the model name is model dot joblib. So yeah, let's dump it. It will take some time, just yeah. So we are done with the saving the model and vector. Next thing we will do is we will go to the VS Code, and there we will just deploy our model. So let me tell you what does mean by VS Code. VS Code is a platform where you can write code easily, and I hope, like, I'm hoping that you guys know this thing, VS Code thing. So I don't have to explain you about the VS Code thing. So here you can download the VS Code. So you can download here, and after downloading this, just make sure that you have clicked option there which is called open the VS Code thing. So let me show you in my the folder. So here you will have the vectors.joblib and model.joblib, and then what you have to do is just you have to just click the right click here, and here you have to just do it open with code, and I will just click that. So yeah, I have clicked that, and in some minute we will see the whole VS Code thing. Okay, just give me a moment. Yeah, it is coming out. So yeah, we have whole things, and now here what I'm going to do is I will create a py functions, a py file actually, which we will use for deployment things. So I don't need the WL Linux thing, so it just take time, you know. So let me just create a new file called main.py. You have to do this thing, okay, main.py, and we will have a main.py file, Python file, okay. Let's just go to our browser, and let me just search one thing, which is FastAPI. Okay, this is a wonderful framework actually. This is a high performance or high speed or fast API which you can get in modern day. So this is one of the fastest API you can get. So yeah, so here as you can see, FastAPI framework is high performance, easy to learn, fast to code, and ready for productions. And this all are true. Okay, so let me just do one thing. How to get started with the FastAPI thing, that I'm just so we have to just here they have provided how we can start the FastAPI thing. Just simple, you know, you have to go to FastAPI, and here is the installation thing. So what you will do is just copy this thing, Control C, go to your VS Code. Okay, we have the main.py, and right now just create a new terminal here. Okay, new terminal. Okay, so we have the new terminal. So just it's take time because obviously my system is a little bit slow, so it will take some time. Yeah, once we have the terminal open, what you can do is just the copy pasted code that from the FastAPI, you just have to provide that thing. That's it, and the whole thing will be installed and like that. So this command you need to just you have to provide this command and just hit enter, and it will install the FastAPI. I'm not going to install because I have already installed the FastAPI, so I'm not going to install that. Next what we're gonna do is you have to install the UVCon. So in order to run the whole FastAPI framework to the web browser, the UVCon command will help you to run the whole code into the browser. So you need to install this UVCon again. Next, after installing these two things, we will jump to the example that FastAPI has given. So I will just copy here, just see this thing. Okay, let me just zoom a little bit. Okay, so we have to copy this, like, just for learning purpose. I will copy this whole code, and I will go to my Windows, or sorry, VS Code, and I'll just paste here, and then I will simply again I will go here, and simply there is a command called UVCon main :app -- reload, and I will just copy that, and in the cell in the terminal I will just paste that and just hit enter. And after entering, it will take, because of so it will take little bit time. I don't know, it will not take much time. So it just in few seconds or few minutes it will give you a link. Here we have, so just control and click this link. Okay, and you will get the FastAPI thing. I think it should work. I don't know why it's not working. Okay, let me just click again. Okay, so yeah, it is working now. So let me just cancel this one. Yeah, it's working. And now if you just go to the docs, now you just slap docs, you will find the Swagger UI, and here is the actually this is quite wonderful in FastAPI, that you will get a Swagger UI where you can just easily you can see the whole thing that you have written in the code, and you can have a user interface here. So this is the Swagger UI, means user interface. That's it. So right now we will deploy the whole thing here. So what I'm going to do is I will just I will delete all these things. Okay, I will just delete. I'll just copy this thing. Okay, and I will here, let me just name it as prediction. Okay, let me just name it prediction, and I will define a function. Let's call get prediction. Here I will give our name, like I will provide a text, and which will give me that, like I will provide a review. Okay, I will provide a review. Okay, I will provide a review where the review will it will goes to our model, and it will give me some result which is positive or negative, like that. So I can, and the review will be a string, so I will provide str. And next thing what I can do is let me just load my model. Okay, let me just load my model. So from job lib, so we have saved the model and the vectors, so I can write from job lib import load, and here I can write like vector equal to vector is equal to load dot what, load our model. So vectors dot job lib. Okay, vector dot job lib, and next thing is model, so I will just load it. Okay, model dot load job lib, I guess job lib. So here we go, we have the vector and the model, and here what I'm going to do is, like I'll just write text equal to what we have, review. Okay, review, and there we can just call vec equal to vector dot transform our text. It will just it will transform the text into vector. This is the code, and now we will just put the vector, and like let me just prediction equal to model dot model. So model dot predict, and here I will provide the vec. And now I need to do one thing, because it will it will provide a numpy array. So what I'm going to do is, like I will just say prediction equal to int prediction, because that is what I need, because I want an integer. So now I will return this thing, return the whole thing in prediction. So let me just put sentence, first sentence. What is our sentence? Sentence is our review. So sentence is the review, and next thing is what we have, next thing, our prediction. So prediction is just prediction. Okay, let's hope it will work. So let's hope, and I will run this thing, and it is running here. Okay, let's just see. So let me just go to my Swagger API, and just again I just press it. Okay, we have something which is predictions, and I will just yeah, we have the review, and I will just try out, and let's just say that movie was great. and just run it, and here we go. Can you see it? Yeah, I hope you can see it. Look at this. So the sentence is that movie was great and the prediction is 1. So for now, like we are getting that thing, but let me just put here like not 1. Let me put here something called what positive or negative, some like some string will be good. So let me just put that thing. Okay, so let me just put that whole thing. So here I can do it here. No, I can do it here. So let me just create a if. So if prediction is greater than 0, okay, prediction, prediction equal to positive, okay, and else prediction equal to what, negative. Okay, now it will look quite better from previous. So let's just save first. Okay, so I will again just do this thing and let's just try it out. Okay, and I will say it was again, let's just that movie was quite great. Let me just again run it. Okay, and here we go. That movie was quite great. And okay, so we are getting something, and let me just quite boring, not boring, let me just not at all good. Okay, not at all good. Let's execute this thing, and here we go. It's negative sentence or negative review. So in this way you can just deploy your whole deploy your model into productions. And here it will give you a link so that you can just put here. Okay, and you are good to go. And here is the whole the web page where you have a sentence and you have a prediction. And now you can there are several things you can do. Something called post, like here we can, instead of getting the whole thing, we can post our review, and it will give us a prediction. So we can do that. For that we can do one thing from Pydantic, import something called base model, I guess. So base model, and I can just I can create a class. Called get review. Okay, get review, and here I can put the base model. Okay, so that we can have, and here I will just simply put the review. Okay, I'll just simply put the review. Okay, let me just indentation right. Okay, review, and which will be str. Okay, the review will be str, and I'm doing this thing little fast, I know, just bear with me. And if you don't understand any of these things, just comment me out, or just re-watch this video, because I think the whole video is getting lengthier and lengthier. So that is why I'm just doing it little bit fast, So we have the get review thing, and now I can call the get review. So I can, instead of this thing, I can call the get review. So get review, and here we go. And so I will just put this thing, and yeah, I will just change this thing, and instead of get, I will do the post. Okay, and I think we are good to go, I guess. So let me just again go to my Swagger API, and yeah, we are getting a post thing. So let me just try it out. Yeah, here we go. And I just let me just, that movie was great because I'm yeah, that movie was great. Again the same thing. Okay, so here we can just execute and we make it. Yeah, we are getting the response body where we just have the sentence and the predictions. So in this way you can create or you can deploy the whole thing, in this way you can deploy your machine model into productions using FastAPI. So I hope like just uh, now, like I can say that now you have done an end-to-end machine learning project or a machine learning kind of thing. So congratulations, because if it is your first project, then you can easily put up anywhere, and it's up to you. So yeah, congratulations again. There are something I need to tell you, that again, here are some of the like I can say that movie was great. Let me just say it. Okay, that movie was good, just only good. And if I execute it here, you will get something like this, negative. And why it is negative, I don't know, because good is a good thing. Like some people say, okay, that movie was good, but like it is not bad, but it's still predicting as negative, and that is a bad sign. So what are the improvement we can do? Okay, what are the improvement we can do? And that is the second thing, like that is the last post analysis thing that we will do. And after that I will leave it whole thing to you, and you can improve the model up to, like, from, like, this is the baseline model, you can improve to the state of the art thing, like to the Bert model. So let us discuss about that just in a second. Now the question is how we can improve the whole model, in order to in order to in order to get the better performance, and for that, what we can do several things. For example, we can change naive bias, for from naive bias, it is just a baseline model, because in order to understand a model, like from only naive bias, by using naive bias, if we are getting that much of accuracy, that much of result, just think how much we will get by using logistic regression. And that is the one thing that you should like this is something that you should do. Try logistic regression, try random forest random forest, try or may just remember, you have to do the hyperparameter tuning, because if you don't do the hyperparameter tuning, you may not get the best result out of it. Then you can do XGBoost. There are lots of model you can do, and this is only the machine learning thing. Next come the deep learning part. So how we can improve? Okay, before going to deep learning, what I can suggest you, that instead of trying out only the count vectorizer, you can try TF-IDF. You can try TF-IDF. You can try word to vec. You can try glove, and another one which is quite bit popular right now, which is fast text. You can use this kind of vectorization technique in order to improve your whole model. These are the improvement thing that you need to do in machine learning thing. And coming to deep learning part, so what you can do in deep learning part is, like, first you can try, because of these are sequence, like the movie review is a text and text is a sequence. So you should go RNN thing, where you can use the LSTM. RNN means recurrent neural network. Okay, you can use the RNN, and where you have the LSTM thing, and you can just use the LSTM. Next is the most state of the art thing, Bert. Bert. And this is the last thing, this is the kind of best thing you can do with this data set, where you will definitely get the best result, I can say. And like, if you are a beginner, just don't jump into Bert, because you need to understand how these are working. So don't just jump to Bert. You just first try those logistic regressions, random forest, decision tree, XGBoost, then the LSTM, then you should come to Bert, so that you can also appreciate how Bert is, like how Bert will give you the result. And these are some of the stuff you can do to improve your model. And this is the, like, here is your first step. This is the first step, and there are lots more things to do in this model. And this is the last thing, because from there we don't have that much of thing to improve on. So Bert will be your last thing to experiment. So do try with it, and please do let me know if you are how much performance you are getting, what is the result you are getting, does your model are improving or not. Please do let me know in the comment box. So yeah, that's it for now, and thank you for watching the video.